Okay, let's talk about what these lines are. These lines are called, these lines right here, they're called the absolute value. Yeah, those are absolute value bars, right? And they mean something, okay? So I want you to know what the absolute value means when you see the absolute value bars. The absolute value actually means the distance away from zero. So under here, okay, Miss Bennett's going to write a little bit smaller. All right, so that way we can get it in here. But under here, you're going to write absolute value, and you're going to write what it means. Okay, so there we go. Okay, so absolute value. Okay, so that's the bar, and it's the distance away from zero. Okay, so before we even start solving the equations, I'm going to give you an example. Well, I'll give you an example over here. So if I have an equation that's the absolute value of x equals 3, I'm saying what number has a distance away from 0 that's 3? That's 3 units away from 0. Well, what number is 3 units away from 0? 3. So I know the answer to this is x equals 3. But guess what? There's one other number that's 3 units away from 0. -3 is also 3 units away from 0. So if we look at the number line, guys, and I'll just plot that number line. You are on fire. I love it. Okay, so I'm going to put the number line down here. If I look at the number line and I have 0 in the middle, okay, over here is -3. That is 1, 2, 3 units away from 0. Over here is 3. 1, 2, 3. It is also 3 units away from 0. So notice I have two values that could be the answer to what x is. It could be -3 and it could be 3. And so for that reason, we are going to do these steps in order to solve for an absolute value. Your first step is to make sure the absolute value expression is isolated. Isolated means that it is by itself. Just like we want x by itself, we want to make sure the absolute value expression is by itself. The second thing we want to do is set the inside of the absolute value equal to both the positive and negative number from the other side of the equation. Okay, so we're going to take the inside, set it equal to the positive and negative number of the other side of the equation. The third thing that we're going to do is solve both equations. Okay, we'll solve them both. And the last thing we're going to do is write your answer as a solution set. Okay, this is a solution set. This is when we have more than one solution. I use brackets, okay, and I'm going to put my solution set in there. So in this case, our example that we did over here, we would have a x equals -3 and 3. That's our solution set. Are we all on the same page? Okay, so let's look at number 1. We're going to do exactly what they say. We know we can get two answers out of this because we're talking about distance, both on positive and negative side. So I'm going to make sure my absolute value is by itself. It is. We're good to go. And then I'm going to set whatever is inside, which in this case is x, equal to the positive and negative of whatever is outside, which in this case is 2. So I know the answer is x equals 2 and x equals -2, the positive and negative. All right, guys, go ahead and do number 2. with me. Tell me, what would M equal? All right, we go through the steps. Absolute value is by itself. It's isolated. Now we're going to set both sides. Hold on. Miss Bennett forgot her last step. I forgot to write number 1 as a solution set. X equals my brackets -2, 2. Sorry, I forgot that. There we go. Now, guys, I want you to do number 2. Do exactly what we said. Okay, it's isolated. I see some of you already put in the answers in the chat box, face-to-facers. What would this be? Alex, what would M equal? 14 and? Yeah, and -14. And I'm going to do my solution set. M equals my brackets, okay? And then I would have -14, 14. All right. Let's go to the next one. I'm going to put this on pause. Okay, so let's look. We go through each step. Step number 1 is to make sure the absolute value is isolated. Okay, it is isolated. It's by itself. Step number 2 is set what's inside to the absolute value equal to the positive and negative of the outside. So the inside of the absolute value is 5z. I need to set that equal to 40. And then I also need to set 5z equal to -40. Okay? Then what am I going to do? Well, it said to solve both of these equations. So let's solve the left equation first. If I solve the left equation, I'm dividing both sides by 5. I get a z equals 40 divided by 5, which is 8. One equation, I need to solve that equation, okay? Which means I divide both sides by 5. And I get a z equals -40 divided by 8, which is -8, okay? What is my solution set? Well, z, I keep writing x. Miss Bennett keeps writing x. But it is z equals, I do the weirdest brackets too, -8, 8. There's our solution set. All right, -8 and 8. So are we seeing how even if inside the absolute value is a little bit more complex, we're still doing the same thing. We just need to make sure we solve both equations, okay? Let's look at number 4. We're going to make sure the absolute value is by itself. We're good to go there. We're going to set what's inside equal to the positive of the other side of the equation, so +28, and then the negative, okay, -28. And then we solve both equations, which is step 2. So the first equation, the left side, I'm going to divide by -7 on both sides, and I end up with an a equals -4, okay? And the right side, I'm going to divide by -7 on both sides. And I end up with a equals +4. Okay? And I'm going to draw my solution set. A equals -4, 4. Not so bad. No, this isn't that bad. All right, let's go to the next one. Is the absolute value by itself? Yes, it is a low. So, Kamari, I go inside. I take d plus 1. I'm going to set it equal to 8. And then d plus 1 set equal to -8. So, I have d plus 1 equals 8. Then d plus 1 equals -8. All right. I am going to solve the left and right side. So for the left side, I'm going to subtract 1 on both sides. I end up with a d equals 7. On the right side, I am going to subtract 1 on both sides. Be careful now, guys. Be careful. Don't assume that it's always going to be the positive and negative of the number. It doesn't work like that. When I subtract 1 this time, I end up with a D equals negative 15. Does everybody see that? So don't just think, oh, it's going to be the positive and the negative. No, 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 no. It doesn't always work like that. It doesn't always work like that. Are we all on the same page? With that being said, guys, I do my solution set. I got a negative 15, 7. All right. Guys, on the next one, W minus 3 equals 4. I need to make sure the absolute value is by itself. Is it by itself? Yes, so I'm good to go, all right? So I'm going to say W minus 3 equals 4, and W minus 3 equals negative 4, the positive and the negative. I need to solve both equations. On the left side, I'm going to add 3 to both sides, okay? So I would end up with a W equals 7. On the right side, I'm going to solve that equation, and I'll be subtracting 3, or adding 3, to both sides. This time I end up with a W equals negative 1, okay? W equals negative 1. I'm going to do my solution set for W. W equals a negative 1, 7. How are we feeling, guys? How are we feeling about those absolute values? Yes.
For number 5, how for the D plus 1 equals negative 8, how is it 15? Wouldn't it be negative 9?
Yeah, what is Miss Bennett? You know what? I was looking at that because I was like, that doesn't seem right. Yeah, I don't know why, but Miss Bennett's mind is thinking this is 7. She can't read her own handwriting. You're so right, guys. That is not right. And I was like, that doesn't feel right. What is going on there? You are right. It is definitely negative 9 because that is a 1, not a 7. Miss Bennett, yeah, it's negative 9. That is right. Thank you. Okay, so this is negative 9. Negative 9, 7. Thank you. All right, guys, let's go to the next one. Let's go to the next solution set, okay? The next one says something interesting, and I'm going to pause this. Somebody help him out. Kamari, what is the first step with this? Not distribute. What do you, huh? Yeah, okay, so it's isolated. It's all by itself. So what do we do next?
Set up the equation.
How?
4 and plus 5. 2.
Equals what? And then what?
You do.
Before we do that, we also have to say 4n plus 2 equals what, guys? Negative 34. That's how we're going to handle it. We're going to do exactly what Kamari said. First, we're going to make sure that the absolute value is by itself. Once we know it's by itself, we'll go ahead and take what's inside of the absolute value out, set it equal to the positive and negative of the other side of the equation. So let's solve for the left side. I'm going to subtract 2 from both sides, okay, on the left. and I get 4n equals 32. And then I'm going to divide by 4 from both sides, and I would get n equals 8. Now I'm going to do the right side equation. I'm going to subtract 2 from both sides, and I get 4n equals negative 36. And then I'm going to divide by 4 from both sides, and I get n equals negative 9. Okay? Solution set. And this goes back. Tia, how would I put the solution set? Yeah, it's going to be, thank you, Uretzi. It's going to be negative 9, comma 8, right? So we want to make sure we do the least, we order our solutions from least to greatest. Let's look at number 8. Okay, let's look at number 8. I end up with I have, first step, I'm going to look and make sure it's isolated. The absolute value is by itself. So I'm going to take what's inside, negative 2v minus 5. I'm going to set it equal to the positive of what's on the other side of the equation, so positive 17. All right? Then I'm going to do the same, and I need a little bit of space, so I'm going to move this over. So I'm going to do the same, negative 2v minus 5, but I'm going to set it to the negative of what's on that equation, negative 17. All right, negative 17. All right, now I am going to go to the left side, and I'm going to go through my steps. I'm going to add 5 to both sides of the equation, okay? So I end up with a negative 2v equals, and for this, let's see, what is it, 22? All right. And then I'm going to divide by negative 2. Divide by negative 2. And I end up with v equaling negative 11. All right. On the right side, I'm going to add 5 to both sides of the equation. Now I end up subtracting. Okay, now I end up subtracting. So I end up with a negative 2v equals negative 12. Okay, and let's move this over. And then I'm going to divide by negative 2 on both sides. And I end up with a v equals 6. So for my solution set, I am going to have v equals a negative 11, comma 6. All right. Now, pausing this with the absolute value, then that is not good. We need to go back to step 1. So go to step 1, which is to isolate the absolute value. Okay? Put that in your notes. Put that in your notes, okay? You need to isolate the absolute value. So if we look at number 9, notice number 9, the absolute value is not by itself. It has this plus 2 here. That is not a good look, guys. We got to get it out of there. Well, how do I move it to the other side? Anybody? How do you move that 2 to the other side to get it out? Anybody? E-learners or face-to-facers? How do you move the 2 to the other side? Would I distribute this in? It's being added to the absolute value. Yeah, that's not probably what we do. Is this division or is this multiplication here? Ah, no. We're going to subtract 2. Yeah, we just subtract 2 from both sides of the equation. And now I can write this as a absolute value of C. The 2's go away. It equals to 10. 12 minus 2 is 10. And now this looks just like what we were doing before, right? Where I set what's inside of the absolute value equal to the other side of the equation. So I would have a C equals 10 and a C equals negative 10. So my solution set, I don't have anything more to do. My solution set is negative 10 and 10. All right. Over here, number 10. Yeah, it's not so bad. Number 10, I'm going to do the same thing. I notice the absolute value is not by itself, so I got to isolate it, okay? I have to move that 8 to the other side of the equation by adding 8 on both sides, all right? When I add 8 on both sides, I end up with an absolute value of y equals 3. And now this looks exactly like what I am used to dealing with, right? I set y equal to 3, and then y equal to negative 3, right? Just pulling it out of the absolute value. My solution set then would be y equals negative 3 and 3. Okay? Now let's look at this situation. This time I'm multiplying something times the absolute value of x. What should I do to get rid of that something, that multiplication? Olivia, any idea? How could I get rid of this 6 to get the absolute value by itself?
Good morning, Civil President. Please stand for the pledge of allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under.
Thank you for dropping that in. Should we, if we're dividing, should we subtract? How do we, if we're multiplying, should we subtract? How do we undo multiplication, guys? Inverse operation. We'll use the same inverse operations. What's the opposite or the inverse of multiplication? Division, yeah. So to get this 6 away, because it's being multiplied by the absolute value, I'm going to divide both sides by 6. Does everybody see that? Yeah. So we'll end up with the absolute value of x equaling 24 divided by 6, which is 4. And then I'll go through my same steps, right? X equals the positive of 4, and x also equals negative 4. My solution set, x equals negative 4 and positive 4. How are we feeling about this stuff, guys? It's okay. All right, I want you to keep the notes, and we're going to finish this tomorrow. Have a wonderful day, guys. We see junk outside of the absolute value. That means that we need to isolate. So I need to get rid of this negative 2. And what I noticed yesterday, a lot of you forgot your inverse properties. It still works the same, okay? Some of you were a little confused when it was with the absolute value, but it still works the same. Just ask yourself, hey, negative 2 is multiplying by that absolute value. You see it's being multiplied. So that means to get rid of that negative 2, what do I need to do, Adriana? If negative 2 is being multiplied, I need to do what? Divide. Yeah, I'm going to divide by negative 2. Make sure you're using your inverse operation. So on both sides, I will divide by negative 2. To the left side, the negative 2's cancel. All right? And now I've did exactly what Kamari said. We've isolated the what was with the absolute value. So we got the absolute value of z plus 3 equals negative 14 divided by negative 2. Well, that's positive 7. Alex, now what was this step? After we go ahead and isolate, what do we do?
Do the same thing, but set it in place.
Huh? Say it again. What am I doing with what's inside? Yes. And first I need to take it out of the absolute value, guys. So once you isolate, the next step, take whatever is inside out of the absolute value. That's a z. Z plus 3 equals 7 is one of the things that I have, but then I also have to set z plus 3 equal to negative 7. And then we got two equations to solve, all right? Two equations to solve. My first one, on the left side, I'm going to subtract 3 from both sides. I end up with a z equals 4. And then on the right side, I'm going to subtract 3 from both sides. I end up with a z equals negative 10. My solution set, okay, well, z equals, and then I do a bracket. It's going to equal negative 10 and 4. Andrew, I look at problem 13. Problem 13 says the absolute value of 2w minus 4 divided by 6 equals 3. Is that absolute value isolated? Step number 1. Is it isolated? No, it is not. How do we isolate it? And look at this. What is 6 doing to that absolute value? Right, so what's the inverse? Yeah, so I'm going to multiply both sides by 6 to get rid of the 6. So guys, just ask yourself, what is, whatever is with the absolute value, what is it doing to the absolute value? And do the inverse of it. 6's cancel. I'm left with absolute value of 2w minus 4. And on the right side of the equation, this equals 3 times 6, which is 18. You're at C. What is the next step? Once I get here, what do I do? What do you do? Be careful. Before you guys go to solve, make sure you don't forget the most important step. You cannot solve this yet. Remember, guys, you have to take whatever is, once you've isolated the absolute value, take whatever is inside of the equation, set it equal to the negative and positive of whatever is on the other side of the equation. So I have to set this equal to positive 18. And then I got to set 2w minus 4 equal to negative 18. Guys, do not forget that step. That is the most important step because the rest of this is very simple. Okay? That is important. Now, after that, you do go on to solve, right? So you do want to solve. And you're absolutely right. You're at the, in order to solve this equation, I'll go ahead and add 4 to both sides. So I'm adding 4. I'll do the left first. Adding 4 to this side. I would have a 2w equals 22. And then I divide by 2 on both sides. And I have a w equals 11. For the next one, the same thing. I add 4 to both sides, but this goes a different way, all right? I end up with a 2w. A 2w equals negative 7. And then I divide by 2 on both sides. W equals, I'm sorry. Guys, this is 2w equals negative 14. And I got ahead of myself. I divide by negative 14, and then you end up with w equals negative 7. Okay? Then you end up with w equals negative 7. All right? The next step, guys, is to go ahead and put it as a solution set. Well, what are my solutions? Well, w equals negative 7 comma 11. All right, -7 and 11. Make sure you put your bracket. All right, number 14. Number 14, is the absolute value isolated? Yes or no, Deliani? No. Okay, so what do you suppose we do? Now, here's the thing. We got to be careful. Before we divide, we want to do our inverse operations backwards. Okay? So we probably don't want to divide first. We probably want to take care of that 3 that's being subtracted. Because remember, we do addition. We handle the addition and subtraction first, and then the multiplication and division. So before we divide, we probably want to do what with this? How will we get rid of this 3? Yeah, we want to add 3 to both sides, okay? So, guys, always handle your addition and subtraction first. This is interesting because now there's 2 things happening to the absolute value, right? So we got to have more steps to get it by itself. Okay, so I get a -10 times the absolute value of h plus 5 is equal to -83 plus 3. Well, I owe $83. I paid the person $3. Now I only owe them $80. All right. Now, Davina, is the absolute value isolated? Still no. Right. Still no. How do we get the absolute value by itself? What do we do now? Yeah, I'm going to divide again by -10 on both sides. Now, guys, I have the absolute value of h plus 5 equals 8. The rest of this is pretty easy. Back to you, Alex. What do I do at this point? Equals what?
8.
And then? Absolutely. Yeah, so I want to set what's inside. Once I have it isolated, I'm setting what's inside equal to the positive and negative of the other side of the equation. So I end up with, on the left side, guys, if I solve this, I'm going to subtract 5 on both sides. And I end up with, again, 5's cancel, h equals 3. 8 minus 5 is 3. And then on the right side, I subtract 5 from both sides. And this is an addition situation. 5's cancel. I get h equals -13. All right. My solution set is h equals -13 and 3. Okay. Now, guys, I'm pausing the video. I want you guys to work on problems 15 and 16. And when you're done with problems 15 and 16, I want you to type done in the chat box. Fractions, yes. So for the first one, I have to get rid of, just follow the math here, guys. For 15, I had to get rid, did we all do 15? No one has questions on 15? I'm just going to talk it out. I had to isolate the absolute value. So I added 6 and I divided by 7. Okay, so I ended up with 4n plus 8 equals 16. And then I took what was inside and separated it, and set it equal to negative and positive 16. Okay, and then we just solved on both sides, subtracted 8 on both sides, right? Divided by 4, and I ended up with an n minus 6. N equals negative 6 and an n equals 2. So there's my solution set. Now look at the one with fractions. I got to do the same thing. I have to isolate the absolute value, right? So I had to add 24 to both sides, okay? When I add 24 to both sides, I end up with a 3 over 2 times 4 times the absolute value of 4r minus 4 equals 3. Negative 21 plus 24 is equal to 3. Okay, so that's the first step. Now I got to get rid of this 3/2 over here, guys. I got to get rid of it. Remember with fractions, when you're getting rid of a fraction, when you do inverse operations, okay? When you do inverse operations, remember we multiply by the reciprocal. So I'm gonna put this in red so you can see what I did. But you want to multiply by the reciprocal. So to get rid of the fraction, I'm multiplying both sides by 2 over 3. All right, that's what I did. And when I did that, it gets rid of the fraction in the front, right? But then I have to multiply by 2 over 3 over here. That's what I did over here. So I had to put the 3 over a 1, right? And then I multiplied straight across. 3 times 2 is 6, and 1 times 3 is 3. 6 divided by 3 is 2. All right? So I ended up with a 4r minus 4 equals 2. How many of you got that far? Let me know in the chat if you got that far. Awesome, awesome. Okay, next step then is to add 4 on both sides. So over to the left, if you add 4, you end up with a 4r equals 6, and then you divide by 4 on both sides, okay? And that would give me a r equals 6 over 4. And then remember, I can simplify both of these. Both of these are divisible by 2. If I divide by 2 in the numerator, I would get a 3. If I divide by 2 in the denominator, I would get a 2. So I know this is r equals 3 over 2. On the other side, I do the same. I add a 4 on both sides. I add 4 to both sides, and I end up with a 4r equals 2, right? Negative 2 plus 4 is 2. I divide by 4 on both sides, and I get a 2r equals 2 over 4. But remember, 2 and 4 are both divisible by 2. So if you divide by 2 on the numerator and denominator, you would end up with a 2 divided by 2, which is a 1, and a 4 divided by 2, which is a 2. 1 over 2. All right? Guys, let's really quickly talk about these special cases. Solve the equation and explain their solution. Well, let's look at number 17. Remember, I told you that the absolute value was the distance away from 0, right? It was how far away a number is from 0, okay? So what number 17 is saying is tell me what number has a negative distance away from 0. A distance of negative 6 away from 0. Now, this is a problem, guys, because if you think about distance, do we ever measure distance in a negative way? Yeah, do you ever say, I went negative 5 miles today? I ran negative 5 miles today. The school is negative 2 miles away from my house. He's negative 3 feet tall, right? That does not sound right. It doesn't, because distance isn't negative. And when you see an absolute value equal to a negative number, there is not going to be a solution. Okay, so there's no solution. It's none, all right? Or you could write no solution, because that's not possible. Let's look at the next one. Next one, let's go through our steps. Let's isolate 18, number 18. Let's isolate the absolute value. We're going to divide by -3 on both sides. Okay, so I divide by -3 on both sides. And then I end up with the absolute value of 2x plus 1 is equal to -7. This is when I say to myself, what? When will I be -4 feet tall, right? When will I walk a -mile, right? Can absolute values be equal to a negative value, Kamari? No, right? So if I see the absolute value of something and it's equal to a negative value, I know that there is no solution. Okay, it's no solution for this. And what is the explanation, guys? No solution, why? What is the explanation? The absolute value, and I'm just going to put the AV. You guys write absolute value. Miss Ben is writing. Well, you know what? I can write it over here. It's easier. Okay, so the absolute value cannot, okay, it cannot equal a negative number and here's the key, guys, after you isolate it. So I'm going to show you example. This is okay. Okay, if I gave you -3 times the absolute value of x equals -21. Well, you would not tell me it's no solution, Miss Bennett, because you need to isolate it first. Once you isolate this, I divide by -3, I end up with the absolute value of x equals 7. This is okay. This is great. This is good. But this is not okay. This is not okay. If I was to give you this, 3 times the absolute value of x equals -21. Of course, you would need to isolate it first. Okay, so you would isolate it, divide by 3, divide by 3. But look what happens. I get the absolute value of x equals -7. That is not good. An isolated absolute value cannot equal a negative number. Are we all on the same page? I know when I see that there's going to be no solution. Okay, no solution. With that being said, guys, that's all I have for